Basically, Git is also known as a version control system. And the general question is, why version control in the first place? Why do we want to do version control? So the thing is, like, it helps us track changes over time. It helps you collaborate better in a team. It helps prevent your code from being, from losing your code. It allows you can go back to previous versions of your code. And the truth of the matter is that you cannot work in any professional environment without it. It's the standard now. It has come to stay. So what is Git in the first place? So Git and GitHub are not the same things. People often interchange them, but Git is the primary tool, while GitHub is just one of the tools that uses Git. We have ones like Bitbucket, we have ones like GitLab, but Git is the primary version control tool. When you talk of version control, Git is what helps us do version control. Git is what helps us track our changes. Git lets us undo mistakes. Git lets us work. Git can work locally on our computers. And then what is GitHub? GitHub is just a website independent of Git. It stores your code online. So different teams can choose to use anyone they want. Some teams will use Bitbucket. Bitbucket still works with Git. Remember, I said Git is the version control system that keeps tracks of your changes, while GitHub or Bitbucket or GitLab is the online, like an online website that will store your Git code. So I'm just using GitHub because it's one of the most popular. But the other ones, apart from GitHub, and always remember Git and GitHub are not the same tool. So GitHub is like a website online that stores your Git code for you. So just think of it like Google Drive or OneDrive or Dropbox, but GitHub is like a Google Drive for Git. So you write your code and Git will keep track of it locally. Any changes you make, Git will be keeping track of it. And then you push it online to like your Google Drive for Git, which is GitHub. I don't know if that makes sense. So people can see that your code online and collect it, collaborate, and so many things. So bringing Git and GitHub together. So this is the real difference. Git will save the different versions of your code, but locally now on your system. While GitHub will help you transport those versions from your local system online and obviously collaborate with other people. So in real life, imagine it like you're writing a book, a recipe book. Day one, you write out 3 recipes in the book. Day 2, you add a new recipe or you fix a typo in the first 3 recipes you wrote. Day 3, you get a new idea, but you regret it and you delete it. All these things are just still on the book now. Nobody is seeing it. It's with you locally in real life. So with Git now, that's literally just Git. Git is tracking everything you are writing in that book. All the typos, all the fix, all the new ideas, the reverting. Git is tracking every version of what you are doing. You understand? Even if you want to go back to day 1, where you wrote 3 recipes, you can delete day 2 and 3. Git is tracking it. It's working on your ideas. It's tracking all your ideas, right? So now with Git itself, it's just very easy. How to get it? You just install it from this website. I'm going to send the slides over, but there's a link behind it. Once you click it, you look at your operating system. If you're on a Mac, you download the Mac version. If you're on your Windows, you download the Windows version. And then you run it like any installer. Anything you download on, for example, Windows, when you download something, you click and install it, right? And then you have Git on your system. That's it. Then all you just need to do is open like a terminal. Essentially, this is a terminal now. If you go to Start, you just type CMD. This is an easier one to use than PowerShell, and you click it and you open it. And once you open it, you just have to configure Git on it by typing this command, git config global username, and then you enter your username, and git config global email, and enter your email. This is just registering the identity of the person to Git. This is just telling Git who you are. So you type them separately. You type the first one, enter. You type the second one, enter. And automatically on that your local system now, Git has registered you as the user on that system. That's it. And the next part, obviously, is to go into the projects you want to use Git with. So if you have a new project, for example, you just created a new folder, and in that folder you have HTML, CSS, JavaScript files. And initially that project have just been on your system, you can turn that into a Git project. So all you just have to do is open your project the normal way on VS Code or anywhere we open it, right? You open you and VS Code. This is why I recommended VS Code from the start, because VS Code has an integrated terminal. So this CMD that I just opened now from our Windows itself, VS Code has its own. So you don't have to be working in VS Code and going back to CMD when you want to write a Git command. You can work in VS Code and use VS Code's own terminal. It's literally the same thing you get in that CMD that you get here. And you're doing everything on one screen. It's easier. So this is why I recommended it from the start. But yeah, so you open your project folder, like maybe our landscapes project, and you just type Git in it in a terminal. So to open a terminal in VS Code, I will still get to the practical parts, but I'm just showing you. You can click terminal up here and say new terminal or shortcut on my keyboard. I don't know what another person's keyboard will be, but on my keyboard is control and single quotes. That opens a terminal for me. That's the shortcut, open a terminal. So once you do that, you just type Git in it in that terminal, and automatically this your whole project will be registered with Git, and we can try it here and see. So me, I already downloaded Git, I installed it, I configured my username. So I don't have to do all of that, but the steps are on the slide. So once you type Git in it, you see initialized empty Git repository, and all of a sudden you see this stuff appear here, 19. So Git is telling me that I have 19 changes. It's now tracking every single thing in my project. And all I just have to do is push it online to Git's OneDrive, which is GitHub or Bitbucket or GitLab, depending on what your team chooses to use. So that's it, Git in it, and all of just like that, Git is tracking my project. And then, so basically, CD the project is just to go into the folder. So you can open the folder in VS Code directly, the way I've shown you guys. Or if you know how to use command prompts, you can use it. But the class is not about command prompts. You can treat that later. But basically, open your project somewhere, preferably on GitHub. Use the terminal, preferably on Visual Studio. Use the terminal in Visual Studio and just type Git in it. And suddenly, your project, Git starts to track everything. And you don't have to type it again for the future. Once you've initialized Git in your project folder, is there for life. So now making changes. So you can check for changes. You can check for the status of the changes you've made using Git status. It's also a command. I'm going to leave it. I left a full list of the commands in the slides as well. So if we type Git status right now in this terminal, you will see these are all the files that Git is tracking. When it's red, it means that the files have not been staged, and I'll explain to you what staging means in a bit. But when it's green, it means that the files have been staged, right? So now back to staging and committing. So staging is basically like putting the files in a basket or in your cart when you go shopping, right? Staging is that process of taking the items and putting them in an environment where you're ready to check out. Checkout is the transporting it to GitHub now. That's it. So commit. So there are different steps. First, you initialize a Git repository. You add files that you want to stage into the staging, right? You commit the files and then you push the files. And the analogy is it's literally what I've said. Staging is like taking those items and then placing them in a basket, and commit is like, sealing up that basket and maybe labeling it, this is this, this is that, and then you transport it online like GitHub, right? So to stage, you just use the add command. That's just it. So all these things, obviously, I'm not expecting them to stick just today, right? I'm not saying that you must know all of them today, but it takes time as you work with them. So every single week, just make sure you push your work, and before you know, by the time you do it twice or three times, you get used to the basic command. So to stage, you say git add. So sometimes you can select the files you want to add. Sometimes you can add everything together. So if I say git add, if I say audios, if I say git status again, you see that audios is now green. I've staged audios now. Is ready to be committed and put online. while these ones are still red, I've not staged them. But let's say everything here you want to stage them. Instead of doing, if you have 1,000 files, you can't be doing git add this, git add that. You just do git add, full stop. And that's it. Everything is staged. So if you do git status again, you see that everything is now green. So these are all my files, our audios, contacts.html, all of our images, our index.html, portfolio.html, our styles.css, all of the videos, everything is now staged, ready to be pushed on Git, right? So the next major command is git commit, basically. So before we enter committing, I'm going to talk a little bit about GitHub. So GitHub is just, to set it up is very easy, just like Git. You sign up, you create a repository. A repository is just basically a folder where Git will store your specific project, because come to think of it, you'll be working on different projects with different individuals that have no business with each other. So everything you put on GitHub has to be in its own folder. Every single project you do has to be in its own folder. So a single folder is a repository. That's just the simplest way to understand it. So all of the version history, everything that has to do with that project, everything would be in that folder, a repo. So basically, you sign up, you create a repo. And how to create a repo, you just go to GitHub, click new, you give your repo a name, and that's it. I can show a quick explanation of that. Let's just go to github.com. Hopefully I'm not logged in. If I'm logged in, okay, I'm logged in, I'll log out just to show you the sign up page. Hopefully I remember my login details. Well, yeah, this is it basically. Once you're signed out, if you go to github.com, this is what you see: sign in, sign up. You sign up with your email and whatever they ask you for. And once you've done that, you sign into your account. Once you've signed into your account, if you want to create a new repository for a project you're currently tracking in Git on your system, you just say new, right? And you give it a repository name. So I'm going to call mine landscapes. So escapes, yeah. So you can give it a description. It's optional. You can give it, you don't have to give it. If you want it private, you make it private. So it's not going to be available to the public unless people you give access to it. But if you want it public, you can leave it public. This one, there's nothing sensitive on it, so I'm just going to leave it public. And also so that you guys can always come back to see it. That's why I'll leave it public. You can see all my code from here. You can clone my work. You can do anything you want to do with it. You can add a README file if you want or not. A README is just like a file where you document everything that your project is about, how people can set it up, how people can run your project. That's just a README file. So you can add it from here if you want or not. You can add a Git ignore template or not. You can choose a license or not. All of these are just optional. I'm just going to say none for now. But basically, this is just it. You put your name, create your repository, and just like that, you have a repository. Finish. You don't have to do anything from here. So the next stage would be to copy the URL of your repository. And this is our repository's URL. If you see now, it has the default GitHub URL, which is github.com. Then it has my username that I used to create my account. And then it has the name of my specific repository. So if I create a new repository, it's going to be exactly like this, but it will be with the last name will be whatever project I created the repository as .git. And this is how you get your unique URL for every repository. All you just have to do is copy that. And then once you've done that, you can now connect Git to GitHub. So to do that, you come back to your VS Code terminal and you just say git remote add, yeah, then origin and the name of that URL. And just like that, Git has mapped this my project to that repository online, right? But we haven't pushed, so this repository will still be empty. We have to push our code up, commit and push. So the next thing is to branch, create a branch. You say git branch. Oh, branch. Why can't I spell branch suddenly? Main. Let's just create our main branch. So we've created a branch called main. So a branch is literally in the word branch. When you think of a branch, maybe a tree branch, how do you envision it? There's a tree here and it has different branches, different numbers of leaves on it, different fruits on each branch, right? That's literally the concept in Git as well. You can have separate branches with different, versions of of code on it, right? So this main branch now that I've just created, I'm trying to push these codes that we've staged into our main branch. So what's the next thing we are going to push? And the command is just git push dash u origin main. So we are going to do that now. First, before we do that, let's commit. I forgot. Because committing is important. When you commit, you have to add a commit message, and it's quite important because that way you can see the description of the history. So anytime you commit a change and push, you're going to add a message to that commit, and the message will be whatever you are pushing at that point. Even if it's one line of change you did, you're going to write that message, whatever you did in the commit, and make it like descriptive and clear. So in this case, what am I doing? I'm pushing I'll just call it landscapes project, which index portfolio and contact pages. That's what I'll just call it. So now we have committed. You see that it has disappeared. It's now ready for pushing. So you just do git push dash u origin main. Main is the branch that we just created. And as you can see, we are pushing everything to GitHub. So even if my computer decides to not work tomorrow again, or it gets stolen, or whatever happens, I have full access to my project. All I just need to do is get a new computer, go to my GitHub and get it, and that's it. I have everything here. Although it's warning me that this video is large, so you probably don't want to push a large video on your page. And to be honest, I should have just deleted it because I actually did not use all 3 videos. I only used one, so I'm going to delete the other 2. But it's good that it's happening like this because it's going to help me show you people how to delete and push again, and you see that the videos are gone. So now this is my repository that was empty. If I'm to refresh, we should see my whole project here. So this is everything. We have everything here, and we have it on our main branch. So our index.html, if you open it, you should see all the code that we've written on it. Every single thing is here. And that's really it. That's like you've just done a full workflow right now of downloading Git, installing it, setting it up on your system, signing up on GitHub, creating a repository, initializing a Git repository on your system, adding it, committing it, and pushing up. And this is it. Anybody can come now, get this project, use it, push to their own branch, and whatnot. So let's continue. So now we have some Git commands. We obviously can't look at all today, but we are going to be looking at some of it, like the most popular ones. We already looked at this one when you first download Git, how to just configure your global username and email. So we talked about this too, and it's something that you guys will have to do because most of you might be downloading Git for the first time. We looked at Git init as well when we initialized the empty repository, and remember I started to track everything in that folder, our landscapes folder. We already did this one, Git clone. We've not done this one, but I'll show you now. So to clone a URL, say you guys now want to take my project online, or you are online, you see someone's project that you like and it's public and you want to clone it. It's really, really easy. You can copy the URL of the project, or the easiest way, and the way I even like to do it, I just go to the person's GitHub page, and I will even use my own so that maybe it's going to be easier for you. I'm just going to use I have 2 GitHub accounts actually. Let me see if I can get any projects from here and clean. So let's say I don't know this person, this is someone else, and they have a public project and I'm interested in that. I could just go on their GitHub, click on this code little arrow, copy this. You want to copy the HTTPS one, not SSH, not GitHub CLI. These are two different setups that we are not treating today. So you want to copy the HTTPS one and you copy it. And all you just have to do is come to Windows, type CMD. This command prompt, you open it. Now, anywhere you want to keep that person's project on your computer, you have to go to that location on your computer. And this is a whole different topic, command prompt. This is a whole different topic on its own. Well, me, I want to keep it on my desktop. So I'm going to do change directory, CD, desktop. This is going to be a whole different course. Don't worry yourself about this ones, this CD, desktop, and the rest I'm writing. Is a whole thing on its own. But then you just have to type git clone, right? And then paste that URL, enter, and it's going to get that project on your system. And if we look in my desktop, let's say I'll open a new VS Code and open my desktop and show you, open folder, desktop. We call it phone store. As you can see, we have that project like that on our system. Everything that the person put online, you have it here. So that's clone. And you can do anything you want to do on this project and push to your own GitHub because it's a public project. But for other projects that you may not have access to, maybe they're not giving you access to clone their repository and stuff like that, there's something called forking, like the mutual fork that you used to eat. All you just have to do is fork the repository. It's going to create a copy of it on your own GitHub for you, right? You can even try that now. So I'm back to my WinYeso. This is my main GitHub. I literally just clicked fork and saying, okay, inside my WinYeso, I'm trying to fork this person's repository phone store from another repository. So it's just going to create a copy for me. And you just have to do create fork. That's it. So if I go back to WinYeso, and I go to all my repositories, I should see phone store as part of the repositories in there, right? Let's see if it's going to be somewhere down here. Oh, I have so much in here. Yeah, so you see we have phone store now in there, and you just have to clone that repository the same way we cloned the other one that was publicly available. You just click it, go to code, and then clone. And so those are the two ways to clone. That's just another git command. Then git status, we already looked at it to check the stage or the status of your files that you are keeping track of. We already looked at git add. And these are just a full list of commands as well. Git add, git commit, we also looked at that. Git log to show a full history of all the commits you've made. We have git diff, show unstaged files only, so files that you've not done git add on. We have git reset, and then the name of the file. So let's say you've done git add on a file, right? You can do git reset, the name of that file. So it's going to unstage that file, so bring it back to red, but to still keep the changes that you made in that file. You just remove it from that staging environment, that green to red. And we have git reset hard. That one is going to reset, is going to unstage and reset the code. It's more destructive, so you have to be careful when using it. We have git rm, then the name of the file to remove a file. We have git branch to list all your branches. So if I come on this VS Code now and do, why does this keep copying stuff? And do git branch, you will see that it will list all the branches I have. For now, I only have name. We have git checkout branch name. So let's say if you want to create a new branch, you can create a new branch. I'll show you how to create a new branch and how to check out within multiple branch. So if I want to create a new branch, I will do git checkout -b and the name of the branch. Let's say I want to call the branch development. Just like that, as you can see, this place I've changed to development. So if I do git branch again, you see that I now have two branch, and the green one is the one you're currently on, the one with the asterisk. So if I want to check out back to main, I'll just do git checkout main, and that's it. Now I'm back to main. If I do git branch again, you see that I'm now on main again. So that's just it. So you check out different branches. Let's say maybe you have multiple branches. Usually there's a main branch. Main branch is the one that is where your final code, your clean and tested code goes to, right? But we have branches like development where, okay, maybe when people are still developing the application, that's the branch they'll be pushing to before they review it and they are sure. Then they'll go and merge whatever changes on that development to main or master branch. Master branch or main branch, remember, is always the final, the cleanest branch where you connect online for people to use. So sometimes, even outside of development, you can have your own branch. We have feature branches. Feature branches is, let's say, there's a very big application we are creating and there are like 10 developers building different parts of that application, right? Every developer will have their own feature branch, right? So for example, now, let's say I'm supposed to add about page to this and another person is supposed to add services page to this website. I can just create my feature branch, git checkout -b feature / about, right? And now I'm in feature / about. If I do git branch, you see that's where I am. So here I can just add about.html, and that's it. I don't even have to write anything inside, to be fair. If we do another git status, you'll see that we have about page. So if I'll add it first, remember this is the flow, you add it. If you do git status again, you see that it's now green. You've staged that file. So you can do git commit. And your commit message always has to be, how do I call it? You have to write it. There's an English word for it. It's just skipping me now, honestly, but you have to write it as if it has to be a doing word, not a past tense. So basically, like I would say, instead of saying added about page, I would say add about page. It has to be action. Yes, it has to be the action you are doing. So add about page. That's it. I've committed it. And if I do git push, so now you have to push to the branch that you just created, feature / about. Sorry, git push. Oh, geez, git push origin. Feature / about. And it's going to push it. So if we go back to my GitHub online, and we go to that landscapes repository, landscapes repo, we are going to see that we now have 2 branches there, right? So we have, you see, feature / about had recent pushes 16 seconds ago, and in here we have 2 branches, right? So in feature / about, we have about.html as well as every other thing. While in main is still clean. Main doesn't have about page in it. So until you are very sure that everything you've done in this other branch, you want it, then you can now merge it to your main branch. We even have branches for fixing bugs. Let's say there's a bug that needs to be fixed. You create a fix / the name of the issue, right? And then you fix on that branch, you push it. And usually, when you're working in a professional environment, there's something called pull request. So when you push a new branch, you will even see it on top. They'll say compare and pull request. A pull request or PR, you just basically have to add the title. So now in the title, you can use past tense. You can just do about page. Let's just call it about page. Then in the description, you can just say added about page. And you can do proper markup. You can make it bold. You can add bullet points. You can make it clean. You can write a full clean description, right? And then you can add reviewers. Usually when you are working in a professional environment, there will be other people that are connected to the same GitHub accounts, right? Or Bitbucket accounts. So you can choose the people you want to review this code. Usually is your senior or your head that has to review. If your code is okay, they will merge it to the main branch or the development branch. But if it's not, they will request for the changes and you can make change, push again, and they'll review it. And then But back to what I was saying, you create your pull request. You click create pull request button, and just like that, you've made a pull request. And when the people are done reviewing it, if it's fine and nothing is wrong with it, you see it. Winifred wants to merge one commit into main from about. So you can just do merge pull requests and confirm merge, right? And before you know, everything is there. So if you go back to the code in the main, you can see we now have about because we've merged that pull request that we created. We have git merge as well. This one, you can merge from your command line. If you don't want to merge from this place, you can merge from the terminal here itself, right? So let's say there's no solid example for me to use now, but basically, merge command will merge one branch into the current one you are. So let's say online, I have another branch, let's say services page, future/services, that's the name of the branch, right? Let's say I have that branch online. I can just pull that branch and or fetch that branch and merge the changes from that branch into my current branch, right? You can do that. Or let's say someone else online is working on the same about page, but they are working on a different section, a different functionality on the about page entirely from you. You can just pull fetch from maybe the person has worked on the functionality and pushed. So you on your local, you can't get it obviously. All you just have to do, you can just fetch from that about online with git fetch command. So you just do git fetch origin, right? Feature slash about. Typed origin wrong. You see, every command matters. With one typo, it's not going to work. But yeah, so once you fetch, if what you fetched has some changes, maybe someone had worked on changes and pushed initially, you are going to see it in the file. It's going to show you your what you currently have and the changes that just came in. And you can, if there's conflict, you can resolve conflict, and then all you just have to do is merge. So you can also get changes from a branch by doing git pull as well. It's literally the same thing. You're just going to do pull origin feature slash about, and it's still going to pull that branch for you. But the difference between pull and fetch is that pull is going to pull and merge, while fetch is just going to fetch. It's not going to merge the changes. It will wait for you to run merge command by yourself. That's the difference between fetch and pull. So when you do git fetch, you still have to come and do git merge again, this command. But when you do git pull, it does both of them. But the cleaner way to do it now is even git rebase. So most people you're working with, they are trying to keep a clean history. So git rebase is going to get changes from another branch into your local branch, into your local system, but it keeps a cleaner history of the commit. And I can't go through all of this today. We have git stash. So let's say you are working on one branch. Let's say I add something here, doc type HTML, let's just allow it to do this thing for us like this. I don't even know what this is. I'm just allowing the assistant complete it. But let's say we have this page, right? Yeah, nothing fancy. You see that Git is now keeping track that there's a new change that just happened in about.html. Also, let's say I just want to delete video 2 and I want to delete video 3 because they are really large and we don't even need to have all of them. So it's now keeping track. Okay, there are 3 changes now. You deleted 2 stuff and you added 1 stuff to 1 page. So right now, let's say I'm trying to check out to a new branch. Remember, I'm on feature/about and I have changes. But let's look at what stash does. Stash basically it temporarily saves the work that you're not ready to commit. That's what stash does. So if I do, let's just do git stash first. See what happened. Git stash. So you see that it has taken off the whole work. It didn't delete it. It just saved it because probably I didn't want to do it on this branch. Maybe I wanted to do it in another branch or something like that. I don't know. So let's check out git checkout. -b. Let's just call it feature slash. I don't know the name of any other page to use. Let's just call it feature/home. At this point, I'm just writing anything. So I'm on home branch, right? You can now do git stash apply. And you see that I'm on home branch with feature/home. But you can see that it has applied everything that I brought from the other feature/about branch into this branch. So it temporarily saves something that you're not ready to commit on a particular branch. And you can either delete it from there or bring it into a new place if it's that new place you initially wanted it. So that's just git stash. I already talked about git pull. Git pull will fetch from git an online branch and merge. Git fetch will just fetch the changes. Git fetch will just fetch the changes but not merge it. So that's git remote add origin. I've also treated this, but it's just to link your local repository to a remote one on GitHub. Git remote -v to just show your current remote repository link. We can try that. Git remote -v. So it just shows us that we are linked to this repository online. Landscapes github.com/landscapes.git. That's the online repository that this particular project is currently linked to. We have some like git tag. It's to just create a tag like a release version. These are things that you use in teams. It's quite important as part of like standard procedures, standard workflows. And we have git show. It shows detailed information about your commits, your tags. We have cherry pick. You can apply a single commit from another branch. We have git blame. It will show who last changed a line of a file. We have git ignore. This one, you mostly use it when you start working on proper applications like backend. Now, when we enter the backend, you see git ignore in action. But basically, you can create git ignore when you are creating that repository in GitHub, or even from your file like this, you can just create a .git ignore. This is how to create a git ignore. And any file you put in git ignore, Git will not track it again. So I'm going to put, if I try .env, and Git is now showing 5 files. So if I do .env, yeah, so I don't know why it wasn't saving before, but yeah, now you see it's down to 4. So Git is no longer tracking .env. You see .env is no longer part of the things in here. .env, like when we enter backend, I'm sure I will get to use it and I'll explain to you. But what basically just means a place where all your environment variables will store. Environment variables are just like things that you don't want to push online for people to see because maybe they are secret information, right? They are only things that you should have, that your application needs to run. Nobody else needs to know. Say maybe your database connection details, your database password, things like that. You put all of them in .env file and find a way for your application to read it from this file. So this file, you don't want to put it on GitHub where everybody can go and see it. You want to ignore it so that when you are pushing in Git cannot track it. So even if I do Git status again, you will see that it's only Git ignore and these other files here. Git cannot see my .env because I've ignored it. So again, the flow is git add to stage all your changes. So it will move it from red to green. So these are the things that Git is currently looking at pushing online. Then you do git commit -n, and we can just say add git ignore and delete video 2 and 3. This is the name of my commit. Git push origin home. Origin future / home. I keep messing up the names. This is the name of the branch we are trying to push to. Git push origin future / home. So if we go back on GitHub and refresh, you will see that we have 3 branches, main, about, and home that we've just pushed. Inside home, we have git ignore now. But if you look at the main branch, there is no git ignore there because we did not do that change on main branch. We did that change on feature / home branch. So like I said, I already took you through this process before, but you can create a pull request to merge into your main branch. So you can see that you are trying to merge any change inside here into main, into here. And that's it. You just write the description, create pull requests, and you have your pull request. A pull request is just something you create when you want people to review your code and add it to another branch. And if your code is fine, they just have to confirm your pull request and merge it. If it's not fine, they will request for changes and ask you to change, push again, and let them merge. So that's it. So now if I go back to my main branch, you will see that git ignore is now there because I've just merged the changes from feature / home into main. I've gone through all of this before, so I'm not trying to dwell on it too much. So these are just a few basic commands. So again, the workflow I've just explained, this is easy. You can clone a repository online if it's publicly available and free for anybody to access. You can fork the repository. Actually, it is going to create a copy of that repository on your own account. Maybe someone's repository, you like their work, you want to clone it on your system and work on it. But basically, you clone a repository. I showed you how to clone. You just go into the repository, right? Inside the repository, you click on this small arrow on code. You should be on HTTPS and then you copy. When you copy this, all you just have to do is come to your computer, go to Windows, type CMD, click on command prompt, type git clone and paste, enter, and it's going to clone that person's repository on any location you want it to on your laptop. It's going to clone it to this location on my laptop, and now you can start to work on a project. When I upload the video, if you were not here before, you would understand better. So the workflow is that you clone a repository, you create a new branch for your feature or for a new feature or a fix that you want to do. Then you make your changes on that branch, you commit your changes, and then you push your changes to that branch. Now, you go online to GitHub or Bitbucket or whatever tool your team uses. You create a pull request, you add reviewers, you can add reviewers to your pull request based on who on your team you want to review your code, right? If you don't want reviewers, you can just leave it, but create a pull request, add the description of your pull request, and submit your pull request for review. Once your pull request has been reviewed, if there's any changes to be made, usually it's the maintainer of the repository or the manager of your team or the senior developer of your team that will be reviewing your code, or if a fellow colleague like you that will be reviewing your code. So they will review the code. If they want changes, they will request for the changes and ask you to make the changes and push again. If it's fine, once it's fine, they will just merge your pull request to the branch that you are trying to, that you want them to merge your changes into. And that's really it. That's all of it. Some best practices: use meaningful branch names, right? So you just don't want to use branch 1, branch 2, or like silly things like that. You want to use the branch should describe what the change you are making is about. Make small and focused pull requests. So don't bombard one commit and push with so many changes. You should push bit by bit. So for example, now let's say I'm working on this about page and it's a really, really big page. I can just do maybe just the header, and I'll push that change, and then I'll work on the main, and then I'll push that change, right? Obviously, this is a small example. When you're working on big applications, you can don't just bombard, work on different pages, a lot of huge work, and then push. It's harder for people to review and it's harder to catch mistakes. It's better you make smaller, focused pull requests. Then write clear commit messages. I talked about that. When you want to commit your work for pushing, it comes with a message. Explain it, and it has to be action, not past tense. It has to be a present tense. So add about page, add functionality to store user details, add this, fix that, remove this. When you push it online, when you are making your pull requests, in the description, you can now make it past tense. Okay, I added this or added this. So another best practice is really useful that many people don't know is that you always have to pull the latest change from a branch before you start your work. And I'll tell you what I mean by this. Let's say I'm on future/home, right? Or let's say I clone a repository first. I clone a repository. By default, the repository will come in with the actual, what's it called? It will come in with the master or the main branch, like the root branch, the main branch of that repository to come in with. Now, let's say you've been working on that repository, but you don't know what has been going on online. Probably people are also working and pushing. You don't know any changes that have gone online. So it's always important that you pull the latest changes before you start any new work, right? So, for example, I'll give you an example now. You see, I'm back on my main branch, but where is my about page? Where is my Git ignore? They are not here because I was doing them on a different branch, right? But they are online because I created a pull request from those branches and I merged it. But because since when I created this branch, I've not pulled the latest changes. So Git on my local system is not seeing that there are new things that have been merged to that main branch. So you always have to pull the latest changes. Git pull origin, the name of that branch. So Git pull origin main. And now you see that it has brought my about, it has brought my Git ignore, it has removed video 2 and 3 like I've done. And now I have a fresh working branch to use. Another way to pull is to do Git fetch. But Git fetch will only fetch. You have to use your hand and now merge these new things that are coming in. But the cleanest way to do it, I talked about this, is Git rebase. Git rebase origin, the name of origin / main, is going to keep it very, very clean online. So that is the basics of Git. If you are going to go back and watch this video, trust me, you would have 60-70% idea. If you can get used to everything I've said today, you have 60-70% idea of how Git and GitHub works, how version control works in particular, in general, actually. The only thing that will be left for you is making sure that you start to master it and making sure that all of these commands stick in your head, number one. And number two, just improving best practices, learning how different teams work, how they use Git, and doing best practices. So that's it for this class. I'm happy that we're able to make it and do what we need to do. I'll see you guys next week, but just leave me any other questions you have.
All right, thank you.